Lesson 3. The 45-45-90 triangle. You may recall from geometry that when you bisect a square diagonally from one corner to its opposite corner, the result is a pair of identical isosceles right triangles. Each triangle has a right angle and two 45-degree angles, and is called a 45-45-90 triangle. Starting with a triangle that has two legs of length 1, you can use the Pythagorean theorem to calculate the length of the hypotenuse. To do this, plug in 1 for both A and B and solve for C. So the hypotenuse of this triangle equals the square root of 2, or radical 2. You can use this triangle to find the values of trig ratios when theta equals 45 degrees. For example, you already know that the sine of an angle equals O over h, that is, the length of the opposite side of this triangle divided by the hypotenuse. This value equals 1 over radical 2. When a fraction has a radical in the denominator, however, it is customary to rationalize the denominator. That is, change it to a rational number. To do this, multiply both the numerator and the denominator by this radical. The result, radical 2 over 2, is the most commonly accepted value for the sine of 45 degrees. And we will use this value throughout this course. You can use the same method to find the cosine of 45 degrees. Begin by recalling that the cosine of any angle equals A over h. This value equals 1 over radical 2. This is the same value as the sine of 45 degrees, but again, we need to rationalize the denominator. The result again is radical 2 over 2. Follow the same basic steps to calculate the tangent of 45 degrees. To begin, remember that the tangent of an angle equals O over A. Because the opposite and adjacent sides of this triangle are both 1, the tangent of 45 degrees equals 1 over 1, which simplifies to 1. These values for sine, cosine, and tangent of 45 degrees are used frequently in trigonometry, so it's important to know them. To begin memorizing them, note that the sine and cosine values are both radical 2 over 2.